All right. Hello, everybody. My name is Edward Thomson. I am a program manager at Microsoft. I work on Visual Studio Team Services, and I focus on Git and version control within VSTS and our on-premises product, Team Foundation Server. If you're interested in version control like I am, I actually just started a new podcast. I hope you'll check it out. It's called All Things Git. It's nice little stickers up here. There's also a bunch of other stickers for Git and for Visual Studio Team Services if you're interested. Today I'm going to talk about what I call the 5 stages of Git at Microsoft. And it's lessons that we've learned within Microsoft, moving both external customers like you, as well as internal customers like the Visual Studio Team Services team and the Windows team even, into Git at Microsoft. See, within Microsoft, we're undertaking what we call one engineering system. And the goal of one engineering system is to move all the engineers in the company into a best-of-breed set of technologies hosted in Visual Studio Team Services. So we're moving them into the work item tracking in VSTS, we're moving them into Git for their version control, and then the CI and CD pipeline hosted by Visual Studio Team Services. And so, just walking around the Microsoft offices, you can see things like this poster, the 5 stages of Git, where people start out perhaps a little concerned because various teams had their own sets of technologies before we started moving them into one engineering system. They might have built their own sort of version control systems. The Office team and the Windows team were using a version control product that you've probably never heard of called Source Depot. Probably never heard of it because we actually built it ourselves within Microsoft to host our scale of development. And so a number of people were worried that these bespoke solutions that they'd built would sort of be superior to Git in the long run. But ultimately, we're seeing that people are very happy with Git in Visual Studio Team Services because we've actually had to do a lot of work to support them. Because again, before Visual Studio Team Services, so this is actually just a list of org charts from various companies. Let me zoom in on Microsoft's for you. See, before one engineering system, we had people all in their own technologies, and we prefer a slightly more euphemistic term called silos, where, say, the Windows team would build their own stack of technologies. The Office team would build another stack. It was perhaps completely different. The Visual Studio Team Services team would do the same. And that's frustrating because there's a lot of duplication, and there are a lot of people who maybe work on Windows and decide they want to change and move over to the Office team or to the Visual Studio Team Services team, and they have to relearn a whole new stack of technologies. They're not just using the current contemporary industry standards. So moving to, say, Git was actually pretty challenging for us because if you read on the Git website, it says that Git was meant to effectively handle large repositories from day one, repositories like the Linux kernel. Now, as far as open source software goes, the Linux kernel is pretty big. It's a lot bigger than Git itself. Even the Roslyn compiler is only 230 megabytes. Linux has 640 megabytes of source. That's pretty big. My team, the Visual Studio Team Services team, our repository is a little bit bigger. It's about 3 gigs. That's source, tests, documentation, bunches and bunches of resources for those tests. We've got Git repositories checked in and databases and stuff like that to reproduce bugs. But around Microsoft, when I say that I have a big repository, people laugh at me because the Windows repository is a big repository. It's got 4,000 people working in it on a day-to-day basis, and it's got 270 gigabytes of source and test data, all sorts of crazy stuff accumulated over the 20 years that they've been working on Windows. And what we found out was that this was a challenge for Git because yes, the Linux kernel fits, and yes, GitHub does a great job of being the world's largest Git hosting provider. It turns out that we had to do something different at Microsoft. we had to learn how to host the world's largest Git repositories. So we've learned a number of things going down this path of getting all of Microsoft into Git. The first thing we had to learn was how to migrate Git repositories effectively, because you tend not to start out and just one day start a new project and have a humongous Git repository. That tends to be something that you've accumulated over time as a lot of source code, like Windows did over the course of those 20 years. And in migrating a lot of customers, again, both external and internal, we had a lot of successes, but we had even more failures. And with all those failures, there's one thing that we've decided, and that is that we strongly recommend that you just do a tip migration. There are tools like Git SVN and Git TF, Git TFS, both, that do an okay job of migrating history, but they don't do a perfect job. There's really no tool that can truly accurately translate history from one version control system to another. No matter how similar they are, there are always little differences, and so you'll never have a perfect translation. Let me give you an example. In Team Foundation version control and in Subversion, branches live what we call in path space. So you've got a folder called trunk or a folder called main. And then next to that, you've got other folders like, branch 1, branch 2, branch 3. In Git, branches exist at the entire repository level. So that's a slight difference, it seems, but there are more, I don't know, problematic differences. Team Foundation version control has change types that simply don't exist in Git. Like you can accurately rename something in Team Foundation version control. And Git tries to use some heuristics to figure that out. So fundamentally, there are change types that just can't be accurately translated. So if you can't get an accurate migration, why would you, maybe you don't need to do a migration at all. Because if you can't get an accurate migration, you probably can't turn off your old version control systems. You probably need to turn them read-only so that you don't make changes in them anymore, but you might not be able to turn them off at all because you might need that for auditing. You might need that to I don't know, maybe you have to participate in a lawsuit. That's something that happens at Microsoft from time to time. And if you walk into a meeting with a lawyer and say, well, here's my version control history, and it all looks like it was recorded a year ago by some translation script, then your lawyer might have some questions for you about what really happened. And if you can't answer those questions, they might be unhappy. And in fact, you might lose a lawsuit because of it. So we strongly suggest that you don't turn off your old version control server, you just turn it read-only, and instead just do a tip migration. Migrate just the latest history over into Git. And in fact, we have a rather simple migration tool for you to do that. We built it into Visual Studio Team Services. If you're coming from a Team Foundation version control system. Right here I've got a simple project. It's just a little app that plays blackjack checked into Team Foundation version control. If you zoom in up at the top, you can see the TFVC logo instead of the Git logo. When I hover over it, it says it's in Team Foundation version control. If I want to convert this repository to a Git repository, it is super straightforward, especially if I'm doing a tip migration. All I have to do is come down and click Import Repository. And in the source type, instead of Git, I can select a Git import and import something either in a local Git repository or in GitHub, for example. But I can also now select TFVC. There's some nice documentation here because, like I said, there are challenges migrating from one version control system to another. Our documentation will outline all of the sort of gotchas, if you will. And then I can enter the TFVC path. And give my repository a new name. And there is a checkbox to migrate history. I said we recommend a tip migration, and we do, but we got enough pushback from customers that we will allow some history to be migrated. This won't go infinitely. This is really just to help ease the pain of a tip migration having no history at all. Because it tends to be that you look at just, I don't know, a week or two, maybe a month of history at a time. And so this will give you that most immediate amount of history without having to go into your old version control system. I'm going to turn that off, and I'm going to click import, and what it's going to do is it's going to set up a new Git repository within my team project, and it's going to do a tip migration from my TFVC repository. It's going to take just a second, and when it comes back, it's going to navigate me to that new Git repository. So now you can see I've got the Git logo there instead of the TFVC logo. And in fact, I can go ahead and just clone this repository locally. It's going to give me the instructions on how to do that. I can come over to a command line. And git clone it. And there we go. I've got a Git repository right there with apparently bad line endings because it's showing me modified files right after the clone. Whoops, my fault. Yeah, sorry, there's a question.
Yeah, should you convert dollar to a Git repository of each individual project? What's the best approach?
Right, the question is, should I convert a dollar? Should I convert the entire root of my TFVC repository to a Git repository, or should I convert each project? And my guidance would be definitely convert each project. Convert something that, where you used to have TFVC branches, that's the scope at which you should create a Git repository. Okay. Now, of course, if you're not coming from TFVC, this import tool is perhaps a little bit less helpful. However, it's very straightforward to also just do a very simple tip migration manually. Once you've got a Git repository from your existing code base, you've also got to migrate the people. You've got to worry about the teams that were using a version control system that isn't Git and figure out how to get them onto Git. And this is especially problematic if you've got a really large team, like the Windows team of 4,000 developers. So the way we did this at scale was to break the training up into chunks. If you look at every development team, so a development team, at least on my project, on Visual Studio Team Services, is about 5 to 6 people. And so what we did was, taking a look at each of those little chunks of 5 to 6 people, we decided to break that up a little bit further. And we would find a Git expert on each team. We would find a volunteer, really, to be the Git expert on each team. And we would give everybody on the team some training, right? We would sit them down. We would offer them plural site courses. We would offer them documentation. And we would do a little, training ourselves. But not everybody learns the same way. Not everybody learns at the same speed. Some people really need to start using the product, using Git, before they really understand it. So it's really critical to have somebody close to them that they trust, that they already work with, that they can ask questions of when they run into trouble. So we do training for everybody, but we do extensive training for the Git experts on each team. And we know that even they are not going to be able to answer every question, so we make sure that they have a great way to discuss amongst each other when they have questions. So there's basically an escalation path from the team, from some person on the team, to the Git expert, and then up into the group discussion. For us, that's email, but obviously not every company works the same way Microsoft does. Some people prefer Slack, some people prefer, I don't know, water cooler conversations. And then from there, we make sure we built out an even stronger set of core experts. These are the people who know how Git works at a very deep level and should be able to resolve any of these problems. So there's a clear escalation path from one person up into the expert level. Thankfully at Microsoft, these at some point we can reach an escalation level of Git contributors and committers to the actual Git project. However, you know, if you're not fortunate enough to have some of those on staff, then at this point you might have to escalate even further up into perhaps Microsoft or your actual support team. Once we've got people trained and using Git, one of the biggest problems that we face is, what does a branching strategy look like for our products? We wanted to do something a little bit different when we moved to Git. This was actually really important for us because one of the really problematic things about what was Team Foundation Server when I started at the company was the velocity it moved at. We shipped Team Foundation Server in 2005, and then in 2008, 2010, 2012, 2013. That's not very frequent. I mean, even I remember that gap from TFS 2012 to TFS 2013, and we were like, wow, 2 releases in 2 years, that's incredible. That's not incredible by today's standards. We need to be able to ship every sprint in our hosted offering, Visual Studio Team Services. So that's every 3 weeks, and we need to be able to get hot fixes into production immediately, as often as they happen. And so the old branching strategy we used to have wasn't going to cut it. In a typical, and I think this is kind of what the ALM Rangers actually recommended as far as branching strategies go. In a typical branching strategy, you would have a main branch. In my case, in the old days of Team Foundation Server, when we were in the on-premises product using TFVC, we were actually sharing a server with Visual Studio itself, the IDE. So our main branch was actually the Visual Studio branch. And then from there, we would branch off our own branch. We would make a feature branch for Team Foundation Server, and we called it ALM. And every team within Visual Studio would do the same thing. So you'd have the compiler team creating a branch. You would have the IDE team creating a branch, the project team, et cetera, et cetera. And so we would have these really complex merges whenever we tried to get together around a milestone, when we wanted to ship a preview or something. What we would do is we would basically submit our code back into the main branch, and everybody would do it at about the same time. So we actually literally had people whose full-time job it was to merge code. And then once all that got done, then we would take that merged code back into our branch and then continue on. And this would happen a bunch of times throughout the year. And we called it merge hell. And it was. Now, from there, feature groups within the Team Foundation Server team would also create a branch, and they would go through the same branching strategy just a little bit before the snaps back down into the main branch. And sometimes if you needed a feature branch, you could create yet another branch. And there was so much complexity just in merging our code that it was horrible. And we weren't even done yet, because once we shipped a product, we would have to keep release branches around to be able to send out quarterly updates and service packs. So this was an incredibly complex branching structure that had a lot of cost for us, and we knew that we wanted to change that. Fred Brooks, who wrote The Mythical Man Month, had a discussion about organizations and how they build design systems, and attributed it to a guy named Mel Conway. And so the corollary of that really is that we tend to build branching strategies around our organizational chart. At least we used to. With Git, you have a lot newer options for branching strategies. So the idea is that you have sort of a trunk-based branching strategy where you keep your code as close to the master branch as you can, and you make small, simple changes, maybe using feature flags instead of long-running feature branches. And this allows you to have much faster velocity. The canonical example of this is what's called GitHub Flow, where you just have a long-running master branch, you create a new branch for a bug fix, and you get it back into master as quickly as possible. You get it code reviewed and shipped as fast as you can. You do the same thing for new features, but you break them up into smaller chunks. And again, maybe you hide them behind feature flags so that you can get the code into production even if it's not being executed yet. So users won't see it, but it's still there. That reduces the number of merges that you have to do, which increases your velocity. You're not busy trying to figure out how to merge several different long-running features together. Instead, you're just shipping the code. So, and this is a great branching structure if you are able to follow what GitHub does, which is they ship master to production every time something gets checked into it. And that's literally an automation step in their workflow. If you're working on GitHub, github.com, the website, and you open a pull request, when you merge that pull request, there's a deployment done to production. And that's amazing. It's scary the first time you do it, let me tell you. I didn't realize this happened. I was like, somebody signed off on my pull request. This was before I was back at Microsoft when I worked at GitHub. I clicked merge, and all of a sudden I deployed to a few hundred file servers. I was like, oh my God. Thankfully, everything worked out. The problem here, though, is that on most days, it doesn't work like that. On most days, there's a long queue at GitHub because there's several hundred engineers at GitHub now. So one of them says, okay, great. I've got my topic branch ready to go. I'm ready to ship it. And what happens is there are a lot of people in that same state. So you actually have to get in the queue at GitHub and wait to merge your change into master so that it can get deployed, because it's not immediate. First of all, deployments take a little bit of time. There's several hundred servers involved, and it takes time to get your code out to all of them. And then once it is out to all of them, you need to make sure that you didn't break something, right? You need to keep your code a little bit in production just in case, because no matter how good at testing you do, there's nothing that can really test the load that production will give you. So GitHub is actually reaching the scale limits of GitHub Flow, and they're actually a lot smaller than the VSTS team is. So we do something a little bit different. We do something that we call release flow. So we still do the small bug fix and feature branches getting into master as quickly as possible. And we keep master stable and shippable at all times, but we don't actually ship it on every pull request completion because we've got several hundred engineers working in there, and it would just be far too slow. Instead, what we do is we create a release branch. We ship every 3 weeks, which is every sprint for us. So we number our sprints. We started at 1, now we're at 120. Apparently we've been doing this for 120 weeks. 120 times 3 weeks, pardon me. So what we do when we are ready to ship for a sprint is we will create a branch off of master at that point in time. And we'll call it, again, M120 for the 120th sprint. And we will ship M120, that branch, to production. When we are done with milestone 120 and it's time to ship 121 in 3 weeks, we throw this branch away completely. We get rid of it. It's no use to us anymore. And instead, we will create a new branch called M121, again off of master. So we don't have these this hierarchy of branches. We're not creating 121 off of 120. We throw 120 away. So we create a new branch off of master and deploy that to production. Now, the tricky part comes when we have bug fixes. When we have, let's say we have a live site incident in production, and we need to fix that. So what we do there is we actually make the change in master first. Again, everything goes into master first. That is the rule of thumb for our changes, trunk-based development. So if we have, let's say, this topic branch right here that fixes a bug, a live site incident in production, we will get into master first and get it tested. That's almost always the first thing we do with any change. And once we've validated that it works in master, it's gone through our test suites, it's gone through code review. And we do this even in the midst of a live site incident, right? When there's a problem with the service, we still follow this pattern because it's a best practice for us. We want to make sure every mitigation lands in master so that we don't forget about it when we blow away this branch to go to the next sprint. When we validated that it works, we actually make a new copy and cherry pick that into milestone 121. So fundamentally, the fix for the problem in production goes into master, and we get a patch of that into milestone 121. Because again, milestone 121 is only important to us for the 3 weeks that it's in production. Okay, let's actually take a look at what this looks like. So this is mseng.visualstudio.com. This is actually our code. This is the Visual Studio Team Services code base. If I go to the branches, the first thing I see is my branches, and you can see I'm not good at actually cleaning up my branches. Here's some from 2015. Whoops. That's okay. Obviously, it's Git, so you can have a lot of branches. If I go to all branches, though, we can see everything. Let me hit reload. And you can see that I've got this master branch down at the bottom. And again, that's actually our integration branch. There are people working in this right now. It was last checked into 6 minutes ago through a pull request. We use pull requests extensively in our workflow. You can't actually push into the Visual Studio Team Services branches without going through a pull request. We'll talk more about that in a minute. But if I navigate to the list of pull requests, I actually had one pulled up already. Here we go. So this is a pull request going into releases M124. So this is actually going into production. This is to fix a perf problem that we were having that was actually a live site incident in production that needed to be fixed. And so again, I said that everything goes into master first. And so you can see down here in the comments, in the description, there's actually a release sign off to everybody else. So everybody else knows that the fix already made it into master. So again, all our changes go into master first and then go into the actual production. So if I actually click on that pull request that went into master, it's already been merged. So that's why this developer was able to say that it went into master first. Into master first. So it's been completed. You can see the green up there. So this change was code reviewed and then shipped to master before it was gone into production. And we have this button cherry pick. And this is a private extension that we've enabled that allows us to take that change and create a new pull request against a new branch from it. So it goes into master, gets code reviewed, gets submitted, and then we can actually target the current release branch with this change. And it will automatically open up a new pull request. Yeah, there was a question over here. Yes?
What was the problem to use the same branching idea with your previous source control? What specific Git gives you? At least now I still don't understand.
So,
What are the benefits of Git for you now?
So the question was, what are the benefits for Git for us? Team Foundation version control, it's very expensive to create a new branch. You have to be an administrator, first of all. You have to, it takes a certain amount of resources on the server.
But you're limited the amount of branches and it will cost you less.
If you limit, if you limit the amount of branches, it will cost you less?
Yes, you limited that. You limited the amount of branches. So your current approach with branching is really nice. So you can keep your original source control. Why should you use Git?
So I didn't limit the number of branches that I have. Every developer spins up a new branch when they are ready to. Let's talk about this more after. I actually am able to spin up a new branch for every bug fix I create, for every topic branch I create. I just only keep one single branch as the integration point. So the benefit of Git is that I can create all those branches. In Team Foundation version control, we had a multi-level branching hierarchy. We had a branch for the entire company, a branch for my project, a feature branch, but that was it. I couldn't create a new branch myself. If I wanted to isolate my code for a bug fix, for a quick feature, I couldn't actually create a new branch myself. Because branching has costs in Team Foundation version control and Subversion. Branching is basically free in Git. So although I have one integration branch, I have a ton of other branches, right? If I look at my users branches, I mean, I have all these branches, and I can create a new one just at the click of a button.
So you just spread the headache of merging to your developers.
Absolutely we do. We absolutely spread the headache of merging to our developers. And by doing that, we make sure that they do it quickly so that they avoid that headache. So let's, once we've got that code in production, let's talk about how we actually do that protection to make sure that nobody actually pushes directly without a code review. There we go. So again, code integration is quite a challenging phenomenon. So when you've got several hundred to several thousand developers working on a team, one of the problems that you have with Git is that the developers do actually have to do the merge themselves. And they have to do it quite quickly in order to make sure that they don't have merge hell, right? The idea is that you have short-lived branches that you merge quite quickly. So one of the problems with a large team is that in Git, I might download some set of changes. Let's say I clone a repository and I want to make a change locally. So I create a commit and I'm ready to push that to the server. So if I run git push, what'll happen is Git will take my changes, or if somebody beat me to the push, because again, there is higher velocity when using Git. So if I run git push and somebody has beat me to it, what Git will tell me is that I have to fetch my changes, fetch the new changes that are on the server, merge my changes with them, or rebase, creating a new commit, and then I can push again. The problem when you're working in a very large team, especially around a deadline, is that somebody could have again beat me to the push. And this can actually go on and on and on while you're running git push. So it favors the person who's perhaps network-wise closest to the server, who can actually download those changes quickly and push them back up quickly, or who can resolve their merge conflicts quicker. So this is actually no fun at all. And this actually does happen. Like the Visual Studio Team Services team hit this at about 200 to 300 developers. Around crunch time, we would get into these places where we simply couldn't push. We couldn't merge our changes fast enough. One of the solutions here is pull requests. Pull requests actually reduce the scope of the merge and move it to the server, so that as long as I don't have any conflicts with anybody else, I don't have to deal with running git merge at all. So there's no need for me to download my changes locally. And a pull request, the server will take care of updating when the target changes. So this drastically reduces the cycle time. You can actually enforce that all changes go through the pull request workflow, that you can't push directly. So what happens then is if 4 people open a pull request all at the same time, it's going to target the same version, the same tip of master on the server. And with most version control systems, with most code hosting providers, what happens is that, let's say 4 people click merge pull request all at the same time, one of those changes will win and get actually committed, and the other 3, you'll see something like get grayed out. What you'd have to do is reload the page, and then those other 3 will now target that new tip of master. So what happens is you click merge pull request, it was nice and green, and then it turns gray on you. That's kind of a bummer, but it's not the end of the world. But it does lead to a bit of frustration, because again, when you're 300, 400, maybe even 1,000 developers, you're going to get into this state a lot. And you don't want to have to click reload just to make sure that your code gets into master. Visual Studio Team Services actually has a really clever solution to this. If 4 people are targeting pull requests and click merge pull request all at the same time, again, this isn't super common, but once you get into the several hundred developers, it does happen. We build a merge queue. So what happens is we actually line up every pull request in the order that we received the merge button, and then we merge them one after another into each other. One of the problems is that there's not strict integration here. So, you know, we've done a complete code integration, continuous integration test pass on that change against what was in master, and then the same there. So it's not without the slightest bit of risk, but it does drastically reduce the cycle time. That's an excellent question. So the question was, what happens if there's a merge conflict? What'll happen is we will just drop it out of the list. So we will merge the first one against master. We know that this one merges against master, and we run continuous integration on it. But what we don't know is if it actually merges against this other change that actually beat it in the list. If that happens, we simply don't merge it, and we continue on with the rest. It is remarkably unlikely that that ever happened. It has happened to us, but really it literally involves people clicking the button within the time it takes to compute the merge, which is 2 to 3 seconds. So there's a little bit of risk there, but it's very limited. It has actually happened to us, though. So again, because we simply couldn't afford people running git push and avoiding the pull request experience, you can enforce that. So as part of the code integration workflow, you make some changes, you test them locally, you get them code reviewed, you merge them into master, and then you release them. Pull requests really target the build and test through merge steps, and policy enforcement can examine the code review analysis. This is super important for us at Microsoft because we're doing so many changes with so many developers over such a large code base that it's really difficult to do accurate and effective code reviews at that scale. So this isn't a Microsoft project, at least not an internal one. This is an open source project that we use within Microsoft. And you can see here on line 1070, I'm setting ODB to the results of that function. And then 1071, the line right below it, I was trying to test if ODB was null. What I'm actually doing is I missed an equal sign, and I'm setting ODB to null. So that little branch will never get executed. Totally missed this in code review. A human person looked at this code and did not see that. And that's because, you know, if you zoom in, it's there. The problem was, this was in a big set of changes. It was just totally missed because the architecture was looked at. When you have giant code reviews like this, you tend to look at the changes that are affecting the structure. You look at the API, you look at how things are used. You tend not to zoom in and catch one character being different. The nice thing is that computers can do this for us. We can use computers to make our lives easier. We can run static code analysis as part of our continuous integration, and we can enforce that continuous integration through a build pass and by turning it on as a policy. We have a number of policies, at least in Visual Studio Team Services, that you can enable. So let's actually jump in and take a look at what these actually look like. Here I've got another project. This one is a simple C# project. It doesn't play blackjack. It actually shows you a hex dump. And what I can do is I can navigate to my branches tab. And again, I don't have a ton of branches. I'm using a trunk-based branching strategy. But what I want to do is make sure that things get tested before they actually land in master. So I can come down and click on branch policies and say, protect this branch. So code changes must be submitted via pull request, and then I can enable additional requirements based on that. I can enforce that I actually get code reviewers looking at my changes before I click merge. For this, I'm going to set my minimum number of reviewers to 1, and I'm actually going to allow users to approve their own changes. That seems ridiculous. Why would I ever do that? This is actually a feature that we use internally. I turn on the allow users to approve their own changes because I get the traceability of a pull request, and I get the option to have other reviewers look at my changes. But if it's 2 in the morning and Visual Studio Team Services is down, we don't have to wait for somebody to wake up. We can actually get a code change into production immediately. I can enforce a work item linking. If you're familiar with TFVC, you can still turn this on so that work items must be linked so that I know why this change is going into my code. So I still have the auditing trail to know what bug I was trying to fix when I checked this in. Other users can comment on my pull request, and I can enforce that the comment was actually fixed. I'm going to turn that off. I can also enforce a merge strategy, which means that when I click merge pull request, it might do a squash, or it might do some other type of, maybe a fast forward if that's optional. I'm going to leave that stuff off. The most important thing here, I think, work item policies are good. I want to associate a work item with my changes. But the most important thing to me is the continuous integration build policy. So I'm going to select my build definition, and I'm going to keep all the defaults and click save. So now what happens is if I open a pull request, it will have to go through this code validation pipeline. So if I make a change to one of these files, I'm going to make a couple typos. And let me actually make sure that I saved that before I do that. There we go. I think I did. But so now if I run git push origin master, what it would normally do naively without any sort of branch protection on, I'll scroll that up a little bit so the back can see, is that it would just accept that. And now I would have that broken code in master where builds would fail and everybody doing a fetch would, kind of hate me. So now it's telling me that the pushes are rejected and I must use a pull request. So what I need to do now is actually create my own branch, and I can push that branch up to the server. So there we go. Now there's a new branch on the server that I can send a pull request to. If I go back to my code tab, the first thing it's going to tell me is that it sees a new branch. Oh, sorry, I went to the wrong tab. But you can see my broken branch I've pushed up. I can click on that and say new pull request. So now I'm asking the system to merge these changes into the master branch for me. When I click, I can add reviewers, I can add work items. I didn't enforce the work item association, so I'm just going to skip all that. Oh no, I'm sorry, I did actually turn on the work item association. If I zoom in over here, we can see that first of all, I don't have any approvers. Next, I haven't linked a work item to this change, and the build, well, that's in progress, so we don't know what that's going to do yet. But I can approve my own pull request, so I'll go ahead and approve that. Now we've got an approver. Usually, again, you would have somebody else on the team do this. I can link a work item. I'm just going to pick a random number, maybe a smaller number, maybe yep, something, come on. Yeah, apparently I have no work items, it's true. In this whole team project, I don't even know how that's possible. Well, okay, I got a feeling that this isn't going to get merged, especially since the build failed, which again, we knew it would because of that typo. So what this does is it protects the quality of the master branch. It makes sure that you have a gated workflow, so you get a strong code integration, you get all your builds and tests running and have to pass before I can actually get my changes into master. At 300 developers, it is critical that you have this sort of a workflow, or else things are broken. Your master branch is just broken all the time. So these are some of the changes that we've had to enable in Visual Studio Team Services in order to be able to support the size of the Git repositories that exist within Microsoft. So I'm going to stick around for questions. I know that 45 minutes was really quick. I'm happy to continue discussing any questions that you have. And if you'd rather chat online, you can hit me up on Twitter. I'm at eThomson, and we have a bunch of stuff online at visualstudio.com. So thanks so much. I appreciate your time.